In this video, we will learn about electromagnet. So an electromagnet is that which is easily magnetized on passing an electric current through a solenoid and easily demagnetized on switching off the current. When an electric current is passed through a coil of insulated copper wire, magnetic field is produced inside the coil. If an iron sample is placed within the coil, it will become a magnet. However, the magnetization lasts so long as the electric current is flowing through the coil. As soon as the current stops flowing, the iron sample loses its magnetism. So, what is an electromagnet? An electromagnet is that which is easily magnetized on passing an electric current through a coil and easily demagnetized on switching off the current. So, there are two types of electromagnets which are based on the types of shape they are made. First is I-shaped or bar type electromagnet, and second is U-shaped or horseshoe type electromagnet. Firstly, we will discuss about I-shaped or bar type electromagnet. To prepare an I-shaped electromagnet, we take a solenoid coil of thin insulated copper wire. A solenoid coil is a coil of large number of turns of insulated copper wire wrapped closely in the shape of a cylinder. So in this diagram, you can see this is a solenoid coil. It is insulated copper wire which is wrapped around in the shape of a cylinder. This is a solenoid coil. We will place a soft iron bar as the core inside the solenoid. When a current is passed through the solenoid coil, the iron bar is magnetized under the influence of a strong magnetic field produced inside the solenoid. Magnetization of the soft iron bar lasts so long as current is flowing through the solenoid coil. If the current in solenoid coil is switched off, the iron bar immediately loses its magnetism. Now we will discuss about U-shaped electromagnet or electromagnet of horseshoe shape. To prepare a U-shaped electromagnet, we take a U-shaped iron core. Two solenoid coils of insulated thin copper wire are wound around the two arms of iron core. This is arm 1 and this is arm 2. However, the windings on the two arms as seen from the ends must be in opposite sense. So, the windings on arm 1 should look like this, and the windings on arm 2 should look like this. And these two will be joined together. Now moving on, the two coils are joined together and the circuit is completed by connecting a battery, a switch, an ammeter and a rheostat. When an electric current is passed through the solenoid, the electric current in coil of arm 1 is flowing in clockwise direction, but in coil of arm 2 the electric current is flowing in an anti-clockwise direction. As a result, one end of U-shaped iron core develops south polarity and the other end develops north polarity. As soon as the current is switched off, the iron core loses its magnetism. In this part, we will discuss the uses of electromagnets. Electromagnets are used in electric bells, telephone receivers, microphones, electric relays, and various electronic devices, for example, radio set, television, CRO, etc. Giant-sized electromagnets are used in cranes for lifting heavy machineries and bulk quantities of iron and steel. Electromagnets are also used to produce very strong magnetic fields in cyclotron and in MRI machines. Magnetic strength of electromagnet. So we have two ways which can increase the magnetic strength of an electromagnet. First is increasing the solenoid current and the second way is to increase the number of turns on the solenoid coil. Also, if you want to change the polarity of the electromagnet, it can be reversed by reversing the direction of current flow through the solenoid. Let us compare an electromagnet with a permanent magnet. An electromagnet is made up of soft iron, whereas permanent magnet is usually made of steel. The magnetic strength is quite large in case of electromagnet, and in case of permanent magnet, the magnetic strength is not very strong and it cannot be controlled. In case of electromagnet, magnetization lasts so long as an electric current is flowing through the coil, whereas in permanent magnet, as the name suggests, magnetization is permanent in nature. An electromagnet, we can reverse the polarity by reversing the direction of current flow, whereas in permanent magnet, the polarity of the magnet cannot be reversed. I hope this topic is clear to you. Thank you.